All right, welcome back AP Calc for part 4 of lesson 1.1. So we had a lot of topics we're going over here. This last one's just going to be kind of a thought-provoking one where we're talking about what it means to be like a set of all points and how to describe it properly. So look at number 39. All right, it says describe the set of all points, and usually they'll use capital P when we're talking about in a calculus context what a point is. It's just an xy coordinate. So describe the set of all points in a coordinate plane that satisfy the given conditions. So when they talk about something like x equals -2, if your knowledge of linear equations is pretty solid, you recognize that as, okay, that's the special case of y equals mx plus b. It's actually a vertical line like this at x equals -2. I think what the authors of this textbook, though, are getting at is, can you describe that point without just being like, there it is, by actually saying, well, it's a line, but describing it, it's the vertical line, and then a lot of times we talk about axes, y-axis, x-axis, when we're trying to describe like a line. Like we always say, what's the y-intercept? And sometimes we ask what the x-intercept is. Well, this is the vertical line that is parallel to the y-axis. And intersects the x-axis. Intersects the x-axis at this point, -2, 0. So yeah, this is just a good task for really getting after descriptions and being able to kind of describe things in something that is very familiar, but maybe you haven't gone in depth with it as much. Let's check out part B. Part B gives us y equals 3. So again, if you have knowledge of linear equations, you know that is a horizontal line at 1, 2, 3. So that. And if we're talking in the same vein as letter A, you'd say y equals 3 is the line parallel to the x-axis. And this one crosses the y-axis at this point, 0, 3. Make sense? All right, let's check out one that's probably going to be more complicated. X is greater than or equal to 0. So now we're still talking about, keep a consistency in a lot of these things. Like, you said this was a vertical line. So this is going to be maybe a set of vertical lines. Remember, x equals 0 is the y-axis. So we're talking about this axis right here, but also x equals 1, x equals 2, x equals 3, and x equals 1.1, and 1.9, and 1.072 is like all the lines, which when you say all the lines, you're talking about all the points. So it's all these points to the right of the y-axis, also including the y-axis. So a good way to describe that would be x is greater than or equal to 0 is, it's not really a line or a set of lines, it's the set of all points. Let's just say to the right of the y-axis. And it's like including the y-axis, so there's probably a better way to say that. To the right of the y-axis and on the y-axis. So x is greater than or equal to 0 is the set of all points to the right of the y-axis and on the y-axis. Yeah. Okay, what are we at now? Part D. Yes. All right. xy is greater than 0. All right, they're putting them side by side. So when you juxtapose the x and the y, we're assuming multiplication. So when you multiply the x-coordinate by the y-coordinate, when is it positive? When is it greater than 0? And you know, when I'm thinking that, the first thing I thought of was, remember back in trigonometry when we talked about like the different quadrants where sine, cosine, tangent, cosecant, secant, cotangent, where all of those trig functions were either always positive or always negative. Like this idea that this quadrant represents when x is positive and y is positive. So it's kind of like you got x is greater than 0 and y is greater than 0 in quadrant 1. And then over here you got x is less than 0, but y is still greater than 0 in quadrant 2. And then over here you got x is less than 0 and y is less than 0 in quadrant 3. And then you got this going on in quadrant 4. When we take it from that perspective, I think it's kind of, it tells us like we're talking about an entire quadrant of points on the xy plane. So when we multiply a positive times a positive, x times y, you get a positive. It satisfies that condition. Over here, when you take a positive times a negative, you get that, which doesn't satisfy the condition. When you take a negative times a negative, it is a positive. So this one does satisfy the condition, just like that one did. And then this one is pretty much like quadrant 2, where you multiply them together, it is not greater than 0. So given this, it seems that xy is greater than 0 is the set of all points in quadrant 1 and 3. Yeah. I'll write that down. Just so that we're absolutely clear on this, xy is greater than 0 is the set of all points in quadrants 1 and 3. Whew. This is a dandy of a problem, isn't it? Let's get to E. Letter E says, where is y less than 0? Well, that's just like part C was, right? I mean, part C was all the points to the right of the y-axis and all the points on the y-axis. So y is less than 0 would be all the points below the x-axis, right? We're switching gears here because we're talking about a horizontal line now. All the points below the x-axis, since this would be y equals 0, is the x-axis. Yeah. So y is less than 0 is the set of all points. Sorry for the hesitation there. The set of all points below the x-axis. And then we don't have to say not including the x-axis. Well, that would be below. So that's a concise and satisfying explanation for that one. All right, this last one is, we got two absolute value inequalities here. And we talked about that on the last video. So I don't know, if you didn't watch the last video, you might want to tackle something like this. So they're saying that the absolute value of x must be less than or equal to 2, and the absolute value of y must be less than or equal to 1. So if I just used that whole idea of absolute value inequalities, actually mean all you're doing is creating these two corresponding inequalities that don't have the absolute value bars with them. Remember, if it's greater than or equal to, it's going to be or. And these just represents like a whole region of points, either over here or over there, bounded by the specific vertical lines 2 and -2. But they seem to be going in opposite directions. So all these markers are running out. I'm going to try to get some over the weekend here. Hopefully they're showing up on the video. Here's our first vertical line at 2. Everything to the right, I'll just put some arrows indicating all these points, all these points, all these points. If we had crayons and this weren't a whiteboard, we'd color it like mad. And then we'd go left, less than left of this at -2. All right, so we've got that space. In addition, it's shared with not that one. Let's move up here. Y is less than or equal to 1, the absolute value. So when we check it out, over here, was it, no, yes. Oh no. Sorry, this is x is less than or equal to 2. Let me try to change that really quick. Oh boy. So what changes here? This is an and now. Oh, it's just the stuff in between. Yeah, it'd be everything greater than or equal to -2, everything less than or equal to 2, so we would just shade the stuff inside. Whew. Hey guys, it's been a long day. But we're almost there. We can do this. So everything's shaded inside here. Now let's see. I have a blue. Let's see if that works out. Y is less than or equal to 1. That means y is less than or equal to 1 and y is greater than or equal to -1. That's just the whole idea of I've got a horizontal line here, a vertical line there, and it's greater than or equal to -1 and less than or equal to 1. All right, so this is basically where's all the black shaded and where's all the blue shaded here? Well, it seems like this rectangle bounded right here seems to be the region we're talking about. So that x absolute value is less than or equal to 2, and y absolute value is less than or equal to 1, is the set of all points bounded, okay, we got boundaries here, inside the rectangle. Yeah, it's certainly a rectangle here. Oh, we can talk about it in terms of the points on the rectangle. We'll call them vertices. With vertices, like a vertex for a triangle. With vertices -2, 1, 2, 1, 2, -1, and -2, -1. So -2, 1, -2, -1, 2, 1, and 2, -1. All right. Lesson 1, complete.